We're going to get into dividing fractions now. So we just finished with multiplying, and we had talked about finding reciprocals right before this. And the reason why we talked about reciprocals is because we have to use those when we're trying to divide fractions. Instead of dividing a fraction, the process is that you multiply by its reciprocal. So you change the division sign to multiplication sign, and you take the second fraction and you flip it upside down. And then you just do a multiplication problem like we did previously. So for example, if I have 5/8 being divided by 2/3, leave the first fraction alone. So leave it as 5/8. Change the division sign to a multiplication sign and reciprocal that second fraction. So flip it upside down. So now it says 3/2. Check and see if there's anything that you could possibly reduce here, which I don't think I see anything because like 5 and 2, you can't take a 2 out. I can't take a 3 out of 8. So I'm going to go ahead and just multiply across. So I get 15 on top, 16 on the bottom. This one can't be reduced because I couldn't reduce it before, and I can't reduce it anymore because I can't take anything out. What's the matter? All right, next one. Okay, an auger bit advances 1/16 inch for each turn. How many turns are going to be needed to drill a hole that's 5/8 inches deep? So if we're trying to find our 5/8 here, that measurement, and we've got a bit that every single turn causes it to go just a little more, we're dividing that 5/8 by that 1/16. So how would you guys rewrite this problem? Okay, so 5/8 times 16/1. How can you reduce it before we multiply anything? What do we do with the 16? So 8 becomes a 1, 16 becomes a 2, because I divided both of those by 8. So I took 8 divided by 8, 16 divided by 8. So what's 5 times 2? 10. So what would be my label here? 10 what? Turns. Okay, if we have to divide mixed numbers, fractions, or whole numbers, we're going to do something similar to what we did with multiplying. We're going to end up first changing those fractions so that they're improper, because they're easier to work with that way when we're trying to divide things. So remember, that's when you take the whole number times the number in the bottom, add the number on the top, and then you put it all over that original denominator. And then the process is the same thing. Once you've got them as improper fractions, change it to a multiplication problem, switch the second fraction upside down. So for this first one, we have 2.5 divided by 3 1/3. So let's first take this and make it become improper. So 2 times 2 would be 4, plus the 1 on top would be 5. So 2.5 is the same thing as 5/2. Divided by, what would be 3 1/3 as an improper fraction? Well, it'd be 10/3 first, and then when you change it to multiplication, it would split. Can we reduce anything? So 5 becomes a what? And 10 becomes a 2, because we divided everything on those two, we divided them by 5. Okay, so 1 times 3 is what's left on top, which would be 3. 2 times 2 is left on the bottom, which would be 4. So 3/4. Okay, you guys try number 2. Change the first one improper, then multiply by its reciprocal. So what would be 5 3/8 as an improper fraction? 43/8. Let's change this to a multiplication problem. What's the reciprocal of 3? Okay, we can't simplify anything here, so let's just multiply. So we're going to have 43/24. I'm okay if you guys leave it there. Like I said before, it's okay if you have improper fractions. You don't have to change it to a mixed number unless the problem asks you to do that. So I'm just going to leave it here for now. All right, let's take a look at these next couple. These next ones are story problems again. So a developer subdivides 5 1/4 acres into lots, and each lot is 7/10 of an acre. How many lots are being made? So if we wanted to set this up as a problem, you're taking the entire area, which is that 5 1/4, you're dividing it into separate lots, which would be 7/10. So we're taking this divided by 7/10. That would be it written out as a problem. Now we solve it the same way we've been doing the other ones. So how would you guys change 5 1/4 so it's improper? Good, 21/4. 5 times 4 is 20, plus 1 would be 21/4. Reciprocal of 7/10 would be 10/7. Can we reduce anything? You can reduce 21 and 7. 7 becomes a 1, 21 becomes a 3, because we divided those by 7. How about 4 and 10? Can you take anything out?
2.
So we get 2 and 5. So a little messy here. Right now I have 3/2 times 5/1 left. So we get 15/2. So if we think about this, because he would need to know like how many full lots he's able to make here if he does this. So this is the same thing as 7 1/2. So how many full lots?
7.
So there's going to be 7 lots that get made, and there's going to be half of a lot left over. So the developer would have to decide what they're going to do with that half of a lot. Whether they're just going to add it to someone else's lot and increase that price, or see if they can sell it to one of the people, that wants to use it for something. The next one says, how many Velcro fasteners, each requiring 1 3/4 inch of Velcro, can be made from a roll containing 100 inches of Velcro? How would you guys set this problem up? Like, what are we dividing? So how much total Velcro do we have?
100.
So we probably want to divide that by how much each one requires to figure out how many we can do. So 100 divided by 1 3/4. So again, if you need to change 100 to a fraction, 100/1 times, so this would be 7/4 as an improper fraction. So when I flip it, it becomes 4/7. We can't do any reducing, so what's 100 times 4?
400.
Over 7. So this would be if I switch it back. So how many can I make?
57.
Well, I probably don't want to do a 7th though, because that's not going to do me any good. So that 1/7 is going to be called waste. Okay, we've got one more here that's along these lines. So a piece of trophy column stock that is 21 1/2 inches long is cut into 4 equal trophy columns. If 1/16 of an inch is wasted on each cut, find the length of each piece. Okay, so this is going to be cut into 4 pieces. So that really only means that they're cutting it 3 times to get the 4 pieces. So the 1/16 is going to be wasted 3 times for this. So let's figure out the total waste first. So total waste is going to be 3, and I'm going to take it times that 1/16. So total waste will be 3/16. So now let's take the amount that we have and let's subtract away the waste. So the total amount that we started with is 21.5, and we need to subtract 3/16 away from that because that's our waste here. So what I'm going to do is change 1/2 so that it has a common denominator. So I want to get it to be a 16. What do I need to take 2 times to get to 16?
8.
So we also need to do that on the top. 1 times 8 and then 2 times 8. So this becomes 21 and 8/16. And then we subtract 3/16. So what's that going to give me right now?
5/16.
And 21 stays as is. So 21 and 5/16. So now we're doing this into 4 equal trophy columns. So we want them all to have the same amount of material. So the last thing we need to do is take that 21 and 5/16 and divide by 4. So I would change 21 and 5/16 so that it's improper. So it would be 341/16. What's going to be the inverse or the reciprocal of 4?
1/4.
So I'm going to take it times 1/4. I can't simplify anything right now. So this would be 341/64. And then because I'm talking about a real life situation here, I would probably switch this back to a proper or a mixed number. So if I do that, it can go in, 64 can go in 5 solid times, and then there's a leftover piece of 21. And my label would be inches. So that's how long each piece should be in order for me to use up all that. So the last thing I want to talk to you guys about is something called a complex fraction. And a complex fraction is a fraction divided by a fraction, but it's written as like a really big fraction. So it doesn't have the division sign. So when you see something like that, it's called a complex fraction. And what we have to do is separate them out, separate it with the division sign, and then change it so that it's being multiplied by the reciprocal. So it's the same thing as what we've been doing, it just looks different in how it starts. So this first one, I have 6 3/8. That's on top. I'm trying to divide that by 4.5. So the first thing we should do is make these improper. So 6 times 8 would be 48, plus 3 would be 51. So 51/8. 4.5 as an improper fraction would be 9/2. So now we flip that second fraction upside down. So it's times 2/9. Can we simplify anything? What? So 2 becomes 1, 8 becomes 4. We can take a 3 out of both 9 and 51. We can't do 9, but we can divide both of these by 3. And so this is going to become 3. This is going to become 17. And that's about as far as we can take that. So now we just multiply. So we have 17 times 1 over 4 times 3. So what would that equal? And I'm going to leave it there as improper. Okay, last thing here, we have this decimal, we have 0.33 1/3, and they want us to write it as a fraction.
1/3.
So we need to write the 0.33 piece, like we have to figure out how do we write that as a fraction. So what place is like the second 3 sitting in? The hundredths place. So we're going to take 33 and a third and divide that by 100. So if you need to, write it out like this. What would be 33 and a third as an improper fraction? 100 over 3. And the reciprocal of 100 would be 1 over 100. That's going to cancel out here. And we're left with 1/3.